Okay, so this is the final video in the CC8 acids topic, which again only comes up on paper 1, and we're going to be looking at solubility and precipitation reactions. So the last couple of videos we've been looking at how acids and bases react together to produce salt and water. And in the reactions that we have carried out, we have been making soluble salts. So when you form the salt, it is dissolved in water, and then we had to separate it from the water using crystallization. However, some salts are not soluble in water. Some salts will not dissolve. And if you form a salt that won't dissolve, then what you're going to see is you're going to see a solid forming over the course of the reaction. So if you had an acid and a base, you reacted them together to form a salt. If that salt didn't dissolve in water, then over the course of the reaction, you would see that solid begin to form. And this is called a precipitation reaction. In terms of knowing what is going to be soluble and what is going to be insoluble, you have to learn this table, unfortunately. They've got some solubility rules, and I'll go through the table with you. And it tells you that if you've got a salt with sodium, potassium, or ammonium in it, that it is going to be soluble in water. So sodium chloride, that's a salt with sodium in it, going to be soluble in water. Potassium nitrate, a salt with potassium in it, that's going to be soluble. If you see sodium, potassium, or ammonium, straight up, it's going to be soluble. If your salt ends in the word nitrate, so we saw that when we used nitric acid, we made salts that ended in the word nitrate, and all of those salts are going to be soluble in water. So whether it was calcium nitrate or sodium nitrate or copper nitrate, if it ends in nitrate, soluble in water. Most chlorides, so if your salt ends in the word chloride, it is typically going to be soluble. So sodium chloride, soluble. Potassium chloride, soluble. Calcium chloride, soluble. However, if the metal was silver or lead, it would be insoluble. So any other metal in front of the word chloride, going to be soluble. But if it's silver or lead, it's going to be insoluble. Sulfates, just like chlorides, mostly soluble. So I can stick any metal in front of the word sulfate and it's going to be soluble. So I could put magnesium sulfate, soluble. Potassium sulfate, soluble. Copper sulfate, soluble. But if I use lead, barium, or calcium as my metal in front of the word sulfate, that's insoluble. Also soluble in water is sodium, potassium, and ammonium carbonates. Okay, but most carbonates are insoluble. So if it's not one of these three metals, which is the same, actually, sorry, ammonium's not a metal, but if it's not one of these three, which is what we have up here, and it ends in the word carbonate, it's not going to dissolve in water. So if I had anything other than these three, so let's say calcium carbonate, insoluble in water, magnesium carbonate, insoluble, lead carbonate, insoluble. But if I have sodium, it is going to be soluble because all of your sodium salts are soluble. And then again, most hydroxides insoluble in water, apart from again these three. You can put those in front of carbonate and hydroxide and it will still be soluble, whereas most won't. You just have to learn that table, unfortunately. It's not ideal, but you just need to learn it. So we're going to look at some examples of some precipitation reactions, okay? So in these precipitation reactions, what we're going to do is we're going to take two salt solutions and we're going to mix them together. And when we do that, the ions form from the salt swap. So I'm actually going to zoom past that example and I'm going to do some examples with you. So I'm just going to shimmy down here a little bit. All right, so I have got silver nitrate, aqueous, and potassium chloride, aqueous. So I've got two salts, and the aqueous tells me that they are both soluble in water. And what's going to happen when I mix these two salt solutions, sorry, these are salt solutions, so I've got two salt solutions, so you've got salt dissolved in water each time. And if I mix these two together, what's going to happen is that the ions are going to swap. So the silver was with the nitrate on the left, but on the right, the silver is going to be with the chloride. And on the left-hand side, the potassium is with the chloride, but on the right-hand side, sorry, the potassium is going to be with the nitrate. So you're just going to swap them around, and then you have the potassium with the nitrate. Now what I need to do is add state symbols. I need to know the new salt that I've now made Is it going to be soluble or is it going to be insoluble? Well, the first one I've got is a chloride, and if I consult my table, it tells me that most chlorides are soluble apart from silver and lead. So I've got silver chloride, that's going to be insoluble in water, and if it's insoluble in water, I'm going to be using the state symbol S. The other salt I'm making is potassium nitrate. I consult my table and I see that all nitrates are soluble. There's no exception. I can also look here and see that if potassium's in my metal, it's going to be soluble. So all signs point to potassium nitrate being soluble, so it's going to be aqueous. So this does count as a precipitation reaction because I start with two solutions, so two liquids, I mix them together and I form one liquid, potassium nitrate, but I also form a solid. So because I'm forming a solid, I can call this precipitation reaction. And again, I didn't know it was precipitation until I added my state symbols. So you swap the two metals around, but then you add state symbols to see if it's precipitation or not. If we look at the next one, magnesium sulfate and lithium carbonate. So again, all I'm going to do is I'm going to swap these two around. And when I do that, I end up with magnesium with the carbonate, and I end up with lithium paired up with the sulfate. And it doesn't matter which way around you write this. You can write lithium sulfate plus magnesium carbonate, or you can do magnesium carbonate first. It's the same thing each time. So I swap those around, and then I need to see if I have a precipitation reaction. Have I formed a solid? So the first one is magnesium carbonate. Is that going to be soluble? So I move on up here, and I find that carbonates are insoluble in water unless I've got sodium, potassium, or ammonium. I've got magnesium. It's not one of the exceptions. So magnesium carbonate is going to be a solid. I've also got lithium sulfate. I see that most sulfates are soluble, so they do dissolve, apart from lead, barium, or calcium. I've got lithium. It's not one of these exceptions, so it is going to be soluble. So lithium sulfate is going to be aqueous. But again, it's another example of precipitation because I am forming a solid. If we do another one, ammonium and copper, swap places. So I'm just taking the first word, or you could take the second words and swap them around as long as you just end up with a different pairing. So ammonium is with hydroxide this time round. Now you need it with the nitrate. So ammonium nitrate is one. And then my other one is going to be copper hydroxide. And then I consult my table to see if these are soluble or not. So ammonium nitrate. It says here that all nitrates are soluble. It also tells me that all ammonium salts are soluble. So I know 100% that one's going to be soluble, and it's going to be AQ. My other one, copper hydroxide. I see here that hydroxides are mostly insoluble unless you've got sodium, potassium, or ammonium. I've got copper, that's going to be insoluble. This is a solid, so again, another example of a precipitation reaction. So they can ask you to complete one of these reactions and then use your knowledge of the solubility table to assign state symbols. You need to learn the tables anyway to be able to do that. They can also ask you a question about how you would prepare an insoluble salt. So you're basically just describing what we've been doing in these word equations. So you start off with two solutions. Remember, they're both AQ, and if it's AQ, I call it a solution. So I've got two different solutions, and I mix them together in a beaker. When I do this, I'm going to be making a solid, and I'm making another solution. So I am going to end up with a solid, okay, in a solution. To remove that solid, I need to filter. Okay, I filter the mixture and I remove my solid precipitate. Okay, and in this case, we are trying to prepare our insoluble salt. So it's the solid that we are trying to prepare. So once I form that solid, I filter it, but it's the solid that I want to keep. So I'm not going to be throwing that solid away. That's what I want to keep. And once I've got my solid, all I need to do basically is just let it dry. But to ensure I haven't left anything behind, I rinse the beaker with a little bit of water, pour it through the funnel, make sure I've got all of that solid has been collected. And then once I've got all of my solid collected, I place it in the oven to dry off any remaining water. So I'm trying to make this solid, so it's the solid that I'm trying to keep. Have a look at one or two other worked examples. Okay, it says here, using the equation below to predict what you would expect to see. So in this case, they've written out the equation for you. They've given you state symbols. They just want to know what you would see. So you can see you're starting with two solutions. You're making a solid and a solution. Because you're making a solid, you would see that solid form. So a precipitate, which is a solid, would form. And the reason it's forming is because lead chloride is insoluble in water. Another example, describe how you would make that insoluble salt from these two solutions. So they've given you the name of the two solutions. You mix them together. The solid salt will form. You filter to remove that solid salt, and then you rinse it with a little bit of water and you leave it to dry. So again, they are the four things that you would need to write down if asked to describe how you would make an insoluble salt. The other methods we looked at in the last video was making a soluble salt, and we used titration and we used the excess base into an acid. Making this insoluble salt, you're mixing two solutions together. So just make sure you are clear on the difference between the methods. Actually, maybe that's a little bit confusing, so I'm just going to write it out for you. You have got, they might ask you to prepare a soluble salt, or they could ask you to prepare an insoluble salt. When we were preparing our soluble salt, we looked at two different methods. Okay, you're always going to be reacting an acid and a base to produce your soluble salt. But if you were using a solid base, if you used a solid base, or you could be using a soluble base, which is also called an alkali. If you were using the soluble base, you were using a titration. And then if you're using the solid base, then you're using, the method doesn't really have a name, but you're just adding excess base to your acid. Okay, so you're trying to prepare a soluble salt, you're reacting an acid and a base. If your base is a solid, then you're adding a solid base to your liquid acid, you're adding it in excess, and this is the one you add the excess base to the acid, and then you filter, and you're not using an indicator. You don't need one because you can tell the reaction is done when that solid base stops disappearing. And your other method was if you use a soluble base, so a base that's dissolved in water, which is called an alkali. So you're adding an alkali to an acid, so you're adding two liquids together and you're using a titration. So this is the one that had the burette. And you were using indicator, you were using phenolphthalein. And the reason you needed that indicator was because you had to see when the reaction was done. Okay, if you're just mixing two liquids together, there's nothing to see. So you use an indicator to see that it's done. And again, you're using this glassware called a burette. So you're adding the acid to the alkali very slowly and precisely, because if you add too much, there's no way of separating them. What we've just looked at now is making an insoluble salt, so a salt that doesn't dissolve in water, and we did this by mixing two salt solutions. So I wasn't reacting an acid and a base, instead I was just mixing two salt solutions, and I'm not going to write out the method again because it's right here. So you take two salt solutions, you mix them together, you end up forming a precipitate. So one of these reactions that we were looking at a second ago, you form a precipitate, and then you want to dry off that precipitate. So you rinse it and then you leave it to dry, and then you've got your salt. Okay. Sorry, actually, I should mention that in these methods, you form, let's say, soluble salt. You end up at the end with a salt solution, and then you need to crystallize to get your pure salt. So you carry out this method, in both cases you're forming a salt solution. And because you're forming a salt solution, you have to crystallize, you have to heat to evaporate the water, and then you're left with your salt. In this method, you're preparing an insoluble salt. It's not dissolved in water, so you don't need to mention crystallization. As soon as you filter it, you're left with your product. You just need to leave it to dry. So there's nothing else to it than that. I'm going to get you to have a go. I had a few questions. Actually, I'll get you to do these ones. So section B. So you need to complete the following equations. So what you need to do is you need to swap these around, just like I was doing for you, and then you need to include state symbols to tell me if the products that you are making are soluble or insoluble. So you would need to use that table that I had in the video in order to do this. So press pause, have a go, and press play. Sorry, so I've scribbled these in. It's a little bit hard to see, so I'll call them out. So when you're swapping, you end up with sodium chloride and aluminium hydroxide. Sodium chloride is soluble, so I use AQ. Aluminium hydroxide is not soluble, so I use an S. The next one, when I swap them, I get lead sulfate and magnesium nitrate. Lead sulfate is solid, it's insoluble. Magnesium nitrate, all nitrates are soluble, so it's going to be AQ. Then I get copper nitrate. All nitrates are aqueous, so I get AQ, and I get silver chloride. So most chlorides are soluble, but silver is not, so that's going to be a solid. I get potassium sulfate. Potassium salts are always soluble, so that's going to be AQ. And I get copper carbonate. So it says carbonate. Most carbonates are insoluble, so that's going to be an S. Next one, sodium nitrate. Your nitrates are going to be soluble, so that's going to be AQ. And silver carbonate is going to be a solid. Then I've got barium sulfate, which is going to be a solid. Barium is one of the exceptions for the sulfates. And then potassium chloride is going to be aqueous. So swapping them around, and sorry, it doesn't matter if you wrote aluminium hydroxide and sodium chloride. It doesn't matter which way around you put the products, as long as you've got the right words paired up together. And then you just include your state symbols using that solubility table.